Hi, welcome to another video by Emily Learning. So in this video, right, I'll be going through a qualitative analysis question from the A-level H2 chemistry practical exam. Okay, as you know for QA, right, typical type of questions will be testing for cations and anions, redox, that means oxidizing and reducing agent, as well as organic chemistry. So for this video here, we'll be looking at an example from QA organic chemistry. So let's get started. All right, so for the qualitative analysis practical that involve organic chemistry, most of the time you will be asked to test for a certain structure or the presence of certain functional group. All right. Okay, and for some of the questions, right, they will ask you to heat it in a water bath. Okay, so what is a water bath? Basically, right, to create a water bath, what you need to do is to first put hot water into a beaker, okay, and then you put your test tube into it. Okay, if you are not given hot water, what you can do is to place this beaker of water above the Bunsen burner so as to heat it up. Then put in the test tube to heat up the organic compound. Why is it that you will need to heat these organic compounds in a water bath instead of over naked flames? Well, this is because some of the organic compounds are volatile and flammable. Okay, because they are very flammable, there is a hazard or there's a potential hazard of them catching fire. So that is why, right, for many of the experiments involving organic compounds, they might ask you to heat it over water bath rather than directly above naked flames. Okay, but don't worry, if the question didn't ask you to put it in a water bath, most likely it is not so volatile, so it will be safe to do it this way. But if the question asks you to heat it in a water bath, please do it this way. Okay, heat the test tube of organic compound uh, over hot water. Okay, because we do not want to catch a fire during an exam. All right, so now I've talked about water bath. Next, let's look at an example of a QA practical question on organic chemistry. Okay. Okay. Now, so let's look at this. So in this question, right, you are asked to deduce the structure of an organic compound, Fa2. So the molecular formula of Fa2 is C4H8O2. Okay, C4H8O2. So if you look at it, I have 8 hydrogens. So very likely it has a double bond. Okay, C4H8, and there are 2 oxygens. So if you have 2 oxygens, it could be maybe I have okay, so before I do that, so what are the functional groups that you have learned that have oxygen in them? Well, this would be your alcohol, your carbonyl, that means your ketone and aldehyde, and your carboxylic acid as well as your ester. So these 4 groups. Okay, so it could be that we have like okay, and we know that carboxylic acid, COOH functional group will have 2 oxygen. Similarly, ester functional group also has 2 oxygen. So it could be that these 2 oxygens comes from carboxylic acid or esters, or I could have maybe 1 alcohol group and 1 carbonyl group, which results in this 2 oxygen. Okay, so let's take a look at the test that we are supposed to do. Okay, and from there let's deduce what it is. Okay, so if you notice here, it says that do not use the Bunsen burner for heating, use hot water provided. So in other words, right, if the question asks you to heat it in the water bath, what you need to do is to place hot water into a beaker and then put your test tube containing the reagents that you need to add into this um, beaker of hot water. And this is what the water bath is. Okay, now let's look at the test. So in the first test, you're asked to place 2 cm deep of aqueous sulfuric acid in the test tube. Then next, you need to add 10 drops of Fa2, which is this organic compound, followed by 1 drop of aqueous potassium manganate. Warm the mixture in hot water bath for 2 minutes. Okay, so if you see potassium manganate, it other words is telling you that you are testing for you are testing for oxidation, right? So what compounds can be oxidized? Well, I know that there's oxygen here, so very likely, right, alcohols, primary, secondary alcohols can be oxidized. And also my carbonyls can also be oxidized with potassium manganate 7. All right. So pretend you have done the experiment and this is your observation. Sorry. Okay, so you have purple CmNO4 decolorized. So in other words, right, it is an indication that I do have a primary or secondary alcohol or a carbonyl group present. Okay, it is also possible to have an ester group. Okay, but we'll talk more about it later. Okay, before I go on to the other test, I want to talk about this. Notice that they tell you to add 10 drops of Fa2 followed by 1 drop of aqueous potassium manganate 7. Why is it that they only ask you to add 1 drop of potassium manganate? Okay, this is important. You mustn't add excess potassium manganate. Okay, reason is because, right, potassium manganate is purple in color. Okay, when it acts as an oxidizing, sorry, when it acts as a when it acts as an oxidizing agent, okay, it will turn colorless. Okay, and so from purple to colorless, okay, we can see this distinct change. But what if we add excess potassium manganate? Well, oxidation will still take place. Some of the potassium manganate will become Mn2 plus, which is colorless, but the excess one will still remain as manganate, which is dark purple, right? So if you have something that is dark purple and something that is colorless, what is the end color you see? It is purple. Okay, so it is very important, right, for tests involving potassium manganate or tests where it involves going from a dark color to a light color, right? You do not add this reagent in excess. Okay, because if the reagent that you add is in excess, right, you will see the dark color at the end of the reaction and you can't tell whether some of it has been converted to Mn2 plus or is it all of it has been or all of it has remained as MnO4 minus. Okay, so very important when you use potassium manganate, remember that potassium manganate should be the limiting reagent. Okay, don't add in excess, if not you won't be able to see a color change from purple to colorless even though it has act as an oxidizing agent. Okay, so now we have done this. Next, let's look at this test. So place 2 cm of silver nitrate in the test tube. Okay, to test this, add 10 drops of sodium hydroxide followed by aqueous ammonia until a clear solution is formed. Okay, to this test tube, add 10 drops of Fa2, then warm the mixture in the water bath for 2 minutes. Okay, so what are we actually doing? So for most of us, okay, so if you're very familiar with the inorganic QA, qualitative analysis practical, if you add silver nitrate, you think of chloride and iodide, right? And if you get these precipitates, then it is an indication that uh, it, the halide ions are present. Halide ions refers to chloride, bromide, iodide. Okay, but in this question, we are doing an organic QA. So what are we actually doing here? Well, silver nitrate followed by sodium hydroxide, then aqueous ammonia, you are actually creating Tollens reagent. All right. So what is Tollens reagent used for? Well, it is used to test for it is used to test for aldehydes. If aldehydes are present, okay, your Tollens reagent, which is a silver nitrate followed by sodium hydroxide followed by aqueous ammonia, will turn silver in color. All right. So this first step, it involves creating the Tollens reagent. So after you have created the Tollens reagent, then you add in Fa2, okay, to test for the presence of aldehyde group. If aldehyde group is present, then you'll see a silver mirror. So notice this observation here. You see a brown PPT which dissolves in ammonia to give a colorless solution. Basically, this is what happens when you are preparing Tollens reagent in this manner. So when you add silver nitrate to sodium hydroxide, okay, you will get a PPT, okay, which will dissolve in aqueous ammonia to give a colorless solution. So this colorless solution at the end of the day is your Tolles reagent. So when you add Tolles reagent to Fa2, okay, and you wait for 2 minutes, you still get a colorless solution. What does it indicate? It means that there's no silver mirror being formed, and as such, there's no aldehyde group present. Okay. All right, so now let's take a look at these 3 tests. So this first test, it says that you're going to add 1 cm depth of deionized water in a test tube. Then you're going to add 10 drops of Fa2, which is the organic compound that we are supposed to test for. Then 10 drops of aqueous sodium hydroxide. Then you add iodine solution dropwise, okay, until a permanent yellow-orange color is obtained. So what are we doing here? So I'm going to add Fa2 to sodium hydroxide plus iodine. So sodium hydroxide plus iodine, this is your iodoform test. Okay, iodoform test, you use alkaline iodine, which is made out of basically just iodine plus an alkali such as sodium hydroxide. All right, so this is an iodoform test. Then you need to warm the mixture in the water bath for 2 minutes. So you need to place the test tube containing all these reagents in a beaker of hot water for 2 minutes. Okay, so let's assume we have done this test and this is the observation. You get a pale yellow PPT. So when you get a pale yellow PPT, what does it mean? You have positive iodoform test, right? So you either have a methyl ketone or you have a alcohol group that is directly bonded to 1 hydrogen and 1 CH3 group. All right. Next, place about 1 cm depth of Fa2 in a test tube. To this test tube, cautiously add a small piece of sodium metal. So for this test, right, they didn't ask you to do it. That's why they write the observation for you. Okay, the reason why they don't want you to do this is because adding sodium metal to a substance is usually very explosive, because sodium is a very reactive metal. So what they are doing is they do not want you to do it, but they do want you to know that when sodium is added to Fa2, hydrogen is produced. Okay, that is why they give you this observation. Observers observe H2 gas produced extinguishes a lighted spleen with a pop sound. So if we know this, what does it suggest? It tells us that, right, this functional group present in Fa2 is able to react with sodium to give hydrogen. And what are the functional groups that would undergo such a reaction? Well, it will be our alcohol groups, phenols, and carboxylic acid. But remember, recall the molecular formula of this compound is C4H8O2. So that means that it cannot be phenol, okay, because phenol has a benzene ring which needs at least 6 carbons. Since we have less than 6 carbons, there's no phenol group present. So we know that, okay, it produces a pop sound. That means it is either an alcohol or a carboxylic acid group. All right. So lastly, place about 1 cm depth of Fa2 in a test tube. To this test tube, add 2,4-dinitrophenylhydrazine dropwise. So what are we doing with 2,4-dinitrophenylhydrazine? Well, we are going to test for the presence of carbonyl, right? So if carbonyl groups are present, that means you will get an orange PPT. Remember, carbonyl refers to both aldehydes and ketones. So let's see what is the observation. So we get an orange PPT form. So we know that we have either carbonyl, we have a carbonyl group present, so either aldehyde or ketone is present. But in the previous test, one slide before here, recall that we did a silver mirror test and there was no silver mirror being formed. So that means that there is no aldehyde group, right? So now I know that there's no aldehyde group. Okay, then I know that I have an orange PPT form. That means I must have a carbonyl group. So in other words, the carbonyl group present is a ketone. All right. Okay, so now we have completed all the tests required for your QA, your qualitative analysis practical on organic chem. So next, let's do some deductions. So these are the questions. So you need to be able to identify 2 functional groups present in Fa2 and then suggest 2 possible structures of Fa2. All right, so I put all the tests and the observations here so that it's easy for you, for us to refer to. So firstly, we need to identify 2 functional groups present in Fa2. So the first part, I know that I have, it can undergo oxidation. So if it can undergo oxidation, what does it suggest? Okay, so it can be oxidized. So I know that I have an alcohol group. So let me write it down. So I know that it is either alcohol group okay, or carbonyl group present, right? Okay, then let me also write down the molecular formula C4H8O2. Okay, uh, okay, so once I'm done with this, next let's look at the second one. So the second test here, okay, it is we are testing Fa2 with Toland's reagent, and I did not get any silver mirror. So if there is no silver mirror, it means that no aldehyde group present, right? So let me cancel away the aldehyde group, okay? Because this tells us that there is no aldehyde group. So in other words, right, the functional group that caused the decolorization of potassium manganate is alcohol group. Okay, and in fact, only primary and secondary alcohol, because tertiary alcohols cannot be oxidized. Okay, now next I need we go on to this test here. So this test is isoform test, and we have a pale yellow PPT of CHI3 form. So if I have a pale yellow PPT of CHI3 form, right, it means that I have positive isoform test. So isoform test is used to test for structures, right? And we are testing for either this structure here or this structure here. Okay, so now I know, okay, it is either of this structure. Okay, then next I know that it will so let's look at this next test. So this is reaction with sodium to give hydrogen. So in other words, I have carboxylic acid or alcohol group. Okay, but now I know that I have an OH group, I have an alcohol group already, right? So if I have an alcohol group, it takes out one oxygen already. I cannot have a carboxylic acid group as well. So I know that, okay, this one must be due to alcohol. Okay, so let me write it down. So for this test, I know that because there is hydrogen being produced, I have OH or COOH. And because I know I already have an OH group, I cannot have a COOH group, because if you have OH plus COOH, how many oxygen is that? It is 3 oxygen, right? But the molecular formula of the compound given to us has only 2 oxygens. So I can eliminate COOH. Okay, now lastly, let's look at this. Place about 1 cm depth of Fa2 in a test tube. Then to the test tube, add 2,4-dinitrophenylhydrazine dropwise. So I have an orange PPT form, and with that, I know that carbonyl is present. So I have carbonyl group is present. Okay, carbonyl group is aldehyde and ketone, right? Okay, so I know it is either an aldehyde and ketone, and from this test here, the Toland's reagent test, I know that there's no aldehyde group. So therefore, the carbonyl group present must be a ketone. Okay, so I know that this is a ketone. So I know that I have a ketone group, and I also know that I have an alcohol group. Okay, I also know that I have one of this structure here. Okay, so identify 2 functional groups present in Fa2. So I'll write ketone functional group. Okay, and also primary or secondary alcohol. Okay, remember tertiary alcohol cannot be oxidized, so it must be either primary or secondary alcohol. Okay, so now with that, I need to suggest 2 possible structures of Fa2. So I know that the molecular formula of Fa2 is C4H8O2. I know that it has a ketone group or a primary or secondary alcohol. I know that it must have this structure. Okay, either this structure or this structure. Okay, so there are many possibilities. So maybe you can pause the video and try drawing 2 possible structures that have a ketone group, a primary or secondary alcohol, and either one of this structure. Okay, so once you're done, let's continue. All right, are you done? So let's go through. So I know that I have a ketone, I have a primary or secondary alcohol, and I must have the structure. So there are many ways to do it. So if I were to do it, right, what I would do, so maybe if it were me, what I'll do is I will first draw this structure here. So I have COCH3. Okay, then once I've drawn this structure, I still have 2 more carbons, right? So I'll just put them 2 carbons. And I know that, okay, now I have a ketone here already. So another functional group I need is a primary or secondary alcohol. So I could put OH here or OH here. Okay. So that's what I'm going to do. I'm going to put an OH here. Okay. So that is one structure. And I'm going to put an OH here. That is another structure. Okay. Alternatively, I can say that, oh, so I would want to use this structure, right? So let me use this structure. So I will draw this structure. I still have two more carbons. Okay. And I know that I need a ketone group. So in other words, right, the double bond O must be on this carbon, because if it's on this carbon, I'll have an aldehyde group. So I must put the double bond O here. Okay, so let me do it. And this will be a CH3. So these are three possible structures. You only need to write any two of them because the question only asks you to suggest two possible structures of Fa2. Okay. So these are the answers. So you can write this or this. Okay. Yeah. Or you can also write this one here. Okay. Okay. So that's it for this video where we go through an example of a qualitative analysis question that involves organic test. Okay, you'll notice for most of the H2 practical exams, right? For QA when they are doing a qualitative analysis question involving organic chemistry, it usually involves knowing the reactions from topics such as your alcohol, carboxylic acid, and carbonyl group. And in particular, right, the carbonyl group is one of the most popular one because there are just so many tests inside that chapter. Okay, but of course, the questions can also come out from other organic chemistry chapters. Although the carbonyl group, alcohol groups, and the carboxylic acid groups will be the most common. So we have come to the end of the video. So I hope it's useful to you. Okay, and see you.